In the part 1 and part 2 of unit place calculation, we used the cyclicities of digits 0, 1, 5, 6, 4 and 9 to calculate for the unit place. And now in this lecture, which is part 3 of unit place calculation, we will use the cyclicities of digits 2, 3, 7 and 8 to calculate for the unit place. The calculation for the unit place using the cyclicities of digits 2, 3, 7 and 8 is not that straightforward. It is little different when compared to the other cases we have discussed till now. And therefore, this lecture is very important, so try to understand the entire process. Now we will move on to the cyclicity of digit 2. The cyclicity of digit 2 is 2, 4, 8, 6. This means for the increasing powers of 2, we will have 2, 4, 8, 6, 2, 4, 8, 6, 2, 4, 8, 6 and so on. And we have already seen the interval after which the repetition is taking place in this case is equal to 4. Now we will understand how we can use the cyclicity of 2 to calculate for the unit place. If 2 is the unit digit of number n, then the unit digit of n power small n will be calculated as follows. So now we will move on to understand the entire process. We have a number n, and this number n has 2 as its unit digit, and we are interested in finding out the unit digit of n raised to power small n. And for this, the step number 1 is to take the power small n and divide it by 4. By 4 because 4 is the interval of repetition in the cyclicity of 2. And after dividing n by 4, we will note down the remainder of the division. So I hope this step is clear to you. We will divide the power by 4 and we will note down the remainder. And it is easy to understand that dividing a number by 4 will give us 4 possible remainders: 0, 1, 2 and 3. And based on the remainder we are getting after the division, we can easily comment on the digit at unit place of n power small n. So when we divide the power n by 4, we can have 4 possible remainders: 0, 1, 2 and 3. When 0 is the remainder, this means this power n is completely divisible by 4. For example, 2 raised to power 8 will have the remainder equal to 0 when power 8 is divided by 4. So we can replace power 8 by the remainder which is equal to 0. So 2 power 8 we can write as 2 power 0. Similarly, if we have 2 power 4, then 4 when divided by 4 will give us remainder equal to 0. So we can write 2 power 4 as 2 power 0. And we know 2 power 4 will have 6 at its unit place. Therefore, 2 power 0 does not mean we will have 1. It means we will have 6 at the unit place. Similarly, 2 power 8, which results in 2 power 0, will also have 6 at its unit place. This 0 is not the actual power we have initially. This 0 is only the remainder, and therefore whenever we have 0 as the remainder, we will have 6 at the unit place. 2 power 8 will also have 6 at the unit place. So when we divide the power by 4 and we get 0 as the remainder, the digit at unit place will be 6. Similarly, when we divide the power by 4 and if we get the remainder equal to 1, we will have 2 power 1 giving us 2 at the unit place. Similarly, when we have remainder equal to 2, we will have 2 power 2 giving us 4 at the unit place. when remainder is 3, we will have 2 power 3 giving us 8 at the unit place. So 0, 1, 2, 3, these are the remainders, and corresponding to these remainders, we will have 6, 2, 4 and 8 as the digit at unit place, or we can say they are the unit digits. So I hope you now understand how to deal with the case when we have digit 2 at the unit place of number n. To understand this better, we will take one example. In this example, let's say we have a number 262, and this number is having the power equal to 128. And we are required to find the digit at unit place of 262 raised to power 128. Now when we focus on the number 262, we can see that the unit digit is equal to 2, and therefore we can use this rule. And according to this rule, we will take this power, 128 is the power, and we will divide this power by 4 and we will note down the remainder. So let us divide this by 4. We will have 432 times 128. So we are getting the remainder equal to 0. So we have our remainder equal to 0, and when the remainder is equal to 0, the unit digit is equal to 6. So this we can write as 2 power 0, and eventually we will have 6 at the unit place. So in this way we are done with our digit 2. Let's now move on to our digit 3. 3 has cyclicity 3971. The interval will remain equal to 4 in this case as well. And if 3 is the unit digit of number n, then the unit digit of n power small n will be calculated as follows. We will take the power small n and we will divide it by 4, and then we will note down the remainder. If n divided by 4 has remainder equal to 0, we will get 1 at the unit place. If remainder is 1, we will have 3 at unit place, and if the remainder is equal to 2, we will have 9 at the unit place, and finally if we have remainder equal to 3, we will have 7 at the unit place. Let us try to understand how we are getting 1, 3, 9 and 7 as the unit digits for the corresponding remainders. When we divide the power n by 4 and the remainder is equal to 0, this corresponds to 3 power 0, and for example we can have 3 power 0 from 3 power 4. 4 when divided by 4 will give us remainder equal to 0. And 3 power 4 is equal to 81. 81 has 1 at its unit place. So when the remainder is equal to 0, we will have 1 as the unit digit. Now when the remainder is equal to 1, we will have 3 power 1 giving us 3 as the unit digit. When 2 is the remainder, we will have 3 squared giving us 9 as the unit digit. And finally, when we have 3 as the remainder, we will have 3 cubed giving us 27, making 7 as the unit digit. So I hope now you understand how we are getting 1, 3, 9 and 7 as the unit digits corresponding to the remainders 0, 1, 2 and 3. Now we will see one example to understand this concept better. In this example, we have 793 raised to power 73. 793 has 3 as its unit digit, and therefore we can use this rule to find out the digit at unit place of 793 raised to power 73. The step number 1 is to take the power. 73 is the power, and then we are required to divide 73 by 4. 4 18 times will give us 72. 73 minus 72 will give us 1 as the remainder. So we are getting 1 as the remainder, and therefore we will have 3 power 1, which is equal to 3. So 3 is going to be the digit at unit place of this power. For remainder equal to 1, the unit digit will be 3. So in this way, we now understand how to use the cyclicities of digits 2 and 3 to find out the digit at unit place. Now following the same process, we can do the calculations when we have 7 and 8 at the unit place. So try to find out the unit digits for the corresponding remainders in case of digit 7 and digit 8. So this is all for this lecture. I will end it here and I will see you in the next one.